You should be ready to check your answers. So make sure you have both questions done to the best and fix as needed or star and mark as you get them right. For number 1, we're finding the zeros in multiplicity. Again, remember whenever we see the word zeros, that pretty much involves some type of factoring. And the first thing we look for with factoring is our GCF. If you notice, each of the terms have an x, so that means that's the first thing we're going to take out. And we're left with x squared minus 8x plus 16. Well, now we take the inside and we use our Santa hat. So we have factors of 1 times 16, which is 16, has to add up to the middle, which is a negative 8. So to have factors of a positive number that add up to a negative, they both need to be negative, and the factors you should have come up with are negative 4 and negative 4. Since this is a shortcut factoring, we can go directly to parentheses. We bring down our GCF and our two parentheses, x minus 4 and x minus 4. Remember, you could also write this as x parenthesis x minus 4 squared. Both ways would be written correctly. Well, that's the factor part, but now we need to follow the directions and find the actual zeros. So we set each different part equal to 0. Well, the first one's easy, x equals 0. And then we have x minus 4 equals 0, which means x equals 4. And then the last thing is the multiplicity. Well, there's only an x by itself once, so that means this has a multiplicity of 1. The x minus 4 appears 2 times, whether you wrote it with the exponent or wrote the parentheses out twice. So we say it has a multiplicity of 2. Moving on to number 2, sketching the graph. We have to do the same process as in number 1, but then we actually sketch it over onto the graph. So the first thing we look for is, again, a GCF. They each have an x. So x leaves me with x squared plus 10x plus 25. Factor our trinomial. So we're looking for factors of 25 because of the 1 times 25 that add up to 10. Factors of 25 that add to 10, 5 and 5. So when I start bringing this down, x, I can go directly into parentheses, x plus 5 times x plus 5. And again, you could also write that as with the squared. So now we know that this x is equal to 0. And if x plus 5 equals 0, that means x equals negative 5. Well, this one, the 0 has a multiplicity of 1. The negative 5 has a multiplicity of 2. And that's important when we sketch it. So again, we're just sketching here, so we're going to put a dot at 0 and a dot at negative 5, which is over in this direction. Well, I look at my highest degree, my x cubed. It's positive, so that means the right side is going to go up. Since 3 is odd, that means the left side has to do the opposite. So since this is the furthest right dot, this one right here, that means from here it has to go up in order for the right side to go up. Since this is the furthest left dot, from here it has to go down. And also because the negative 5 had a multiplicity of 2, I know that the curve has to form a parabola here. Now again, how far down you go is up to you, but then at some point it goes back up. Since the 0 has a multiplicity of 1, that means it goes straight through it. So again, this part, maybe you went lower, maybe you didn't go as low. That is all the part of the sketch. Here's your homework from last night. This was like problem 1 on the warm-up. They didn't have you sketch any of these, but keep in mind you do need to be able to do that. So 15, multiplicity of 2 and 1 because they actually already solved the zeros for you. 16, they each had a multiplicity of 1, your -2 and -1. 18, x equaled 9 with a multiplicity of 2. Over here, -5, multiplicity of 2. This one was a little bit different in factoring. You had to pull out the GCF, which wasn't just an x this time, it was a 2x, which then left you with x minus 1. Well, if 2x is equal to 0, then x still equals 0, and x minus 1 means x would be a positive 1, and they each appear just one time. Pause this if you need to check any more answers, and then move on when you're ready. We're still working on our zeros, which is also called solving polynomial equations. All the same thing, solving zeros and roots. But we're going to work on some special types today. The first special type is our difference of squares. We've talked about that briefly here and there, but hopefully if you had some trouble today we can clear it up. Well, just like any other polynomial, the first thing we're going to do is factor. But with the difference of squares, inside the parentheses, it's guaranteed that you will always have a plus and a minus, because the middle term cancels out, and that's the only way to make that happen. So once you've set up your parentheses, you set each factor equal to, and just like we've been doing, equal to 0. So our first one is 4x squared minus 25. So here we have a binomial instead of a trinomial to factor, and that's what kind of clues you in that this will be a difference of squares usually. I then look at my individual terms. Difference means minus, so if it's a plus here, this doesn't work, it has to be a minus. Well, 4 is perfect, x squared is perfect, and so is 25. So that's why this could be called a difference of squares. It has to be a minus, everything has to be squares. So we can set up our two parentheses. The 4x squared, well, to get to a 4, has to be 2x times 2x, and to get to 25, it has to be 5 times 5, because those are the square roots of those. So that means we have a 2x in each parenthesis. We have 5 in each parenthesis. And then if you look at the beginning, it says one has a plus and one has a minus. So that's how you factor a difference of squares. But again, it has to have a minus, and all the numbers and variables have to be perfect. Well, now we set each parenthesis equal to 0. So we have 2x plus 5 equals 0, and 2x minus 5 equals 0. Well, in the first one, we're going to subtract 5. So 2x is equal to -5. Then divide by 2. You could turn it into a decimal if you wanted to. You don't have to. You can leave it as the -5/2. Looking at our second answer, this time instead of subtracting 5, we're going to add 5. So I have 2x is equal to 5. Divide by 2. X equals 5/2. So my zeros for this polynomial would be a -5/2 and a +5/2. Sometimes you can also see this written as plus or minus 5/2. Just keep in mind you can write it either way. Now our next problem, again, is a binomial, so we're looking for the difference of squares here. It has a minus sign. 9x squared is perfect, but 14 is not. Well, we can still treat this problem as a difference of squares It's just 14 isn't perfect, so we won't get a nice pretty answer. Well, we know that 9x squared is 3x times 3x, but the 14, we can't actually take the square root of it, so we're just going to leave it as the square root. So when I do my two parentheses here, we know there's a 3x in each. Since 14 can't actually be broken apart, we just write the square root of 14. And then, since it's a difference of squares, it has that minus sign. We put a plus and a minus. So now we set each parenthesis equal to 0. So 3x plus the square root of 14 equals 0. And 3x minus the square root of 14 equals 0. Well, in the first one, we would subtract the square root of 14. So I would have 3x equals negative square root of 14. And then to get x by itself, we would divide by 3. So x equals negative square root of 14, all divided by 3. Now keep in mind, since that negative is outside the square root, it is okay to have that as an answer. Not okay for the negative to be inside the square root. Well, in the second one, the only difference that I'm doing here is I'm adding the square root of 14 instead of subtracting it. So instead of getting a negative square root of 14, I get a positive over 3. So hopefully you're recognizing between these two problems, one will always be a positive answer, one will be a negative. So when you write it, again, you could write it negative square root of 14 over 3 and positive square root of 14 over 3, or put plus or minus the square root of 14 over 3. Both of those do mean the same thing. Here we have your you try problem. So go ahead, try this out, check with a neighbor as you're working through it, and then unpause this when you're ready to check answers. So here we go, 25y squared minus 36. First, we check that it's a minus since it's a binomial, and then 25y squared is perfect. That would become 5y and 5y. 36 is also perfect, 6 and 6. So this one won't have any square roots in it, but square root answers are possible here. So we set our two parentheses up, 5y plus 6 and 5y minus 6. Now we find the zeros by setting each of them equal to 0. So we subtract 6 and then divide by 5. And remember, you do not need to turn these into decimals, you can leave them fractions. So my two zeros are negative 6 over 5. If you solve the second one, that's fine, but keep in mind, for your answers, one will always be positive, one will be negative. So our zeros are negative 6/5 and positive 6/5, or you could have written it as plus or minus 6 over 5. So difference of squares is that process. We have one more type of factoring that we haven't looked at yet, and we're going to look at that today in two examples, and we have a nice little story to tell as well. Well, the first thing is, if we're solving and finding zeros or roots, no matter what kind of polynomial it is, the first thing we do is still to factor. And for sums and differences of cubes, we're going to use what we call the roller coaster method. And that's the story we'll be talking about today. Once we've factored, guess what we do? This should be pretty common at this point. We set each factor equal to 0. No surprise there. Now, with factors of sums and differences of cubes, we're going to get one factor, which we will solve normally. Get this back to being straight. And then we're going to get one factor, one trinomial, that we're going to solve using the quadratic formula. We're going to bring back a lot of previous knowledge here. Now when we solve the trinomial using the quadratic formula, our answer, these zeros are going to actually be imaginary, which means you're going to be looking at a negative inside the square root, which we'll have to fix. Now if you forgot what the quadratic formula is, remember we did the song and the story that dealt with it. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now, let's look at our first problem. 8x cubed plus 27. Well, the first reason we know that it's a sum or difference of cubes is that our highest exponent is a cube, and we have a plus, which means it's a sum. Well, the first thing we have to do is break these numbers apart into their 3 equal pieces. So what number times itself 3 times is going to equal 8? And hopefully you realize it's going to be a 2. And x cubed, that one's pretty easy. To get to 3 x's, you need to have 3 x's. So this is going to be 2x times 2x times 2x. Well, the 27, we need to break that apart into 3 equal pieces. So what number times itself 3 times would be 27? We know it's not 2. And this one becomes a 3. So 3 times 3 times 3. And now for the roller coaster story. Well, the first thing is when you're waiting in line for a roller coaster, when you get to the front of the line, you have a choice to make. And the choice is you either wait for the front car or you wait for the rest of the roller coaster. And if you wait for the front car, you've got a longer wait because there's only one car that you're waiting for, which is why the parenthesis is shorter. And if you're willing to go to any other seat of the roller coaster, then you're not going to wait as long because you have more choices. Well, you are with a group of people, and some decide to ride the first car. So to be fair, someone from the first group and someone from the second group of friends decide to go to the first car. So we have 2x and 3. Now, the next 2 people, they decide to go to the next best spot, which is the second seat. Well, 2x times 2x is 4x squared. So the 2 friends went there. Well, the only other place on the roller coaster that's pretty cool to sit at is in the very back. So the next group of friends go to the very back. 3 times 3, which is 9. Well, now we have to get the rest of it. Well, you're in the roller coaster, you go up the first hill, and after the hill we have a loop-de-loop. So we loop, and that ends up in the middle there. So 2x times 3 is 6x. Now the last thing that we have to look for are signs here. Well, on a roller coaster, you're either screaming and those that don't scream or puke. So people typically either scream on the roller coaster or they puke. So what that means is the same sign, so plus sign because it starts off as a plus at the beginning. Opposite of that is a minus, and the end term is always a plus for the scream or puke. So here's how we factor it. Now we set each of these equal to 0 in order to solve. The first factor is our typical one, the binomial. So we go 2x plus 3 equals 0. So we subtract 3. I get 2x equals negative 3. Divide by 2. So x equals negative 3 over 2. The second one, we're going to be solving using the quadratic formula. So I'm going to still set it equal to 0. 4x squared minus 6x plus 9 equals 0. And with the quadratic formula, we need the letters A, B, and C. So 4 would be A, negative 6 would be B, and that would make 9 C. So we go x equals negative b. Well, b is already negative, so that means when we put it in, it's going to become a positive. Plus or minus the square root of b squared, so negative 6 squared, minus 4, it's always part of the formula, times a, which is the 4, and then times c, which is 9. And it's all over 2 times a, which is again 4. Now remember, with your calculators, the scientific calculators, you can type this part directly into your calculator. Make sure you use your parentheses. So we have x equals 6 plus or minus the square root of negative 108 all over 2 times 4, which is 8. Now remember, we did talk about the fact that this answer would be imaginary, so it does make complete sense that there's a negative inside the square root. Well, let's get rid of the negative. So we have 6 plus or minus I square root of 108 all over 8. Well, 108 is not perfect. You could type that into your calculator and you'll notice it gives you a decimal. So that means we're going to need to apply our chart here. Lots of prior knowledge for these problems. Well, 108 divided by 2. Actually, sorry, let me go do this off to the side so we don't run out of room here. Turns into 54. Divide that by 2 is 27. Now we divide by 3. 9, 3, 3, 3, and 1. Remember, we circle our pairs. They have buddies, so they're allowed to go play outside. So 2 times 3 becomes 6. So we have 6 with the I on the outside and the 3 left over 8. Now we saw problems like this before. So the last step was to look at the 3 outside numbers and see if they were all divisible by something. So 6, 6, and 8. Well, we can divide them all by 2. So the final answer for this one would be 3 plus or minus 3i square root of 3 all over 4. And then we also had the answer way back here of negative 3 over 2. So we're going to add that to our answer as well. And that's how you factor and solve a sum or difference of cubes. There is another one that's called a U-try, but we're going to go ahead and do that one together, working through the steps. So here's our last problem for the day. I know these do take a little bit of time. Well, the first thing we have to do is split these numbers into their cube roots, because it's an x cubed. Well, 64 can be broken apart into 4s. So we have 4x times 4x times 4x. Now 1, just like the square root of 1 is 1, so is the cubed root. So it's going to become 1 times 1 times 1. Now remember, roller coaster story, we'll talk about it one more time. So when you are in line with your friends, your two groups of friends, you get to the close to the front of the line, and you have a choice to make. You either choose to go to the first car, or you choose a seat on the rest of the roller coaster. Well, one person from each group of friends goes to the front. Okay. Now, the next best seat is the one right behind the first car. And these two friends go there. And 4x times 4x is 16x squared. The only other good seat in a roller coaster is at the very back. So these two people go there. 1 times 1 is 1. Well, you've started the roller coaster, you've gone up the first hill, and you run into the loop-de-loops. 4x times 1 is 4x. And now for the signs, remember on a roller coaster, you either scream or puke, hopefully scream. Same sign, going back to the beginning, started off as a minus. So that means a minus, opposite of a minus is a plus, and then the last one is always positive. So now we factored the first parenthesis, we go ahead and set equal to 0. So 4x minus 1 equals 0. So we would add 1. 4x equals 1. Divide by 4. So my first 0 is x equals 1/4. The trinomial when I set that equal to 0, since it's a trinomial, we are going to use the quadratic formula here, which means we need to label A, B, and C, and go directly to the formula. So we have x equals negative b. B's positive times would be a negative 4, plus or minus the square root of b squared, which would be 4 squared, minus 4, which is part of the formula, times a, which is 16, times c, which is 1, and it's all over 2 times 8, which is 16 in this case. Now remember, again, scientific calculator, type directly what is underneath the square root. And that should give you a negative 48. So we have negative 4 plus or minus the square root of negative 48. And then 2 times 16 is 32. Well, first of all, 48 is negative. So we know we're going to be introducing an I here. now I have x equals -4 plus or minus I square root of 48 all over 32. We check if 48 is a perfect number. It's not, so we need to pull out our chart. Divide by 2 turns into 24. Divide by 2 turns into 12. Divide by 2 turns into 6. Divide by 2 turns into 3. Divide by 3 turns into 1. We're looking for pairs. A pair of 2's and a pair of 2's. That's going to make a 4. So I now have x equals -4 plus or minus the 4 from the pairs, the I that was already there, and the number left over, which was a 3, all over 32. Last thing we check for, can the 3 outside numbers, we don't care about the number inside the radical, all be divided by something? They can all be divided by 4. So I have answers of -1 plus or minus 1I, which is the same thing as I, square root of 3 all over 8. And then way back at the beginning, we had our first answer of 1/4. And there are 2 final answers for today.